All right, so there is this question on LeetCode, and it is like find the number of paths through a 2D grid or something like that. Um, and I'm typically not a fan of these sort of algorithm questions just because like it doesn't really tell you about like how a person really can sort of solve problems in the real world. But I saw this one the other day and it seemed pretty cool, because you can kind of use this like in some cases like on back end stuff. I found that sometimes you're going to have to write algorithms with recursion and stuff like that, and I think this kind of demonstrates um, a lot of the algorithms are kind of like the same style, right? They're all kind of like have something to do with recursion usually. Um, and this one does seem like it has like real world application, at least to some extent. So I'll kind of go over how the problem is set up here. Um, this Miro thing used to be something else, but they got acquired, and now it sucks. But basically the problem is, say you have a 2D grid, right? And it's simple at the beginning because, like, let's say that you have like a 2x2 grid. They want you to figure out like how many paths can you take from the first square to the end. And so this one, it seems pretty obvious because you can just go one, so that's a path, or you could do two, that's a path. Okay, so there's only two paths that you can take from the beginning to the end on this one. Okay, but this gets quite complicated if you've got, say, a 3x3 grid. Okay, because now, suck at drawing, because now you could go this way, you could go this way, you could go this way. So kind of gets complicated as you get more squares. So if you draw 4x4 grid, you can see this starts to accelerate in terms of complexity, because now I can go this way, I could go here, I could do something like that, I could do something like that. Okay, so as you start to add like more, as the grid gets bigger, the sort of time complexity goes up exponentially. Okay, and that's kind of like the whole purpose of this, right? So let's see how we can code this thing. Okay, I've got this just a regular JavaScript file. So as we kind of will see, um, as soon as you get a decent amount of squares, like there's millions of paths you can take to get from the beginning to the end. So let's get started. We have a lot of work to do. Not really. It's pretty simple, honestly. So if we were on like LeetCode or something like that, there would be some function that they would expect us to deal with. So for example, count paths. And then they would probably give us like some input parameters like X and Y. So I'm going to just like make a function to log the result for now. Okay. So whatever we return from this function, say it's 1, I can log when I run the code, basically it returns the function. Okay, so when you're doing these kind of like recursion problems, it's important to think about, like, where does the code stop? What is the base case? Okay. So, the base case in this case, okay, the base case for this case is basically going to be like, let's think about this input, right? So, a problem might say should return like 2 for 2 by 2 or something like that. The problems usually have that. Stupid emojis. We're on Mac OS today. But basically, I can write some kind of condition that says, okay, if x is less than or equal to 0, or if y is less than or equal to 0, we can return 0. Okay, because we know that, in some problem like this, if there's no objects, or maybe there's like 1, there's really no path if there's 0, if it's a 0 by 0 grid on either axis. So we can just return 0 because there's exactly 0 more paths that we can take, okay? Now, the other base case that I'm going to write is if x is equal to 1 and y is equal to 1, okay? So, in this case, there's going to be one possible path because it's a 1 by 1 grid. So, it's pretty obvious that there's really nowhere else to go besides, there's one sort of path through that, okay? And you'll kind of see how, why I did this here, okay? Because what I'm going to do now is I'm going to return count paths again, okay? And this is kind of like the crux of recursion, right? Because what you're doing is you're building functions that call itself, all right? So what I'm going to do is I'm going to return count paths, and I'm going to return x minus 1 plus, or I guess I have to put the y coordinate here. So I'm going to return x minus 1 y plus count paths again with x minus, or x, and then y minus 1. Okay, so what we've basically done here is we are returning the possible paths from x minus 1 plus the y minus 1. Okay, so what this kind of looks like in a grid is like when we first call this function, we're going to call it with whatever number of paths. Like, let's just say it's a 4 by 4 grid. Basically, we're going to start at the end of the grid and then work backwards. Now, you can also work forwards as well, but I find that the backwards is basically more efficient, and we'll get into that in a second. So basically what we're doing is we're saying, okay, run this function, start at the end, go up, and then for each of these cases, we run the same function from this point, right? So we're going over and up. And then from each of these points, right, we also go over and up. And each of these kind of spawns a new sort of tree of these recursive functions. So as you can see, it gets pretty complicated pretty quickly if you've got a lot of these squares, right? So let's just try it with 1 by 1. So it's going to say 1, obviously. But if we put 2 by 2 in here, we should get 2, because there's 2 paths that you can take. If we put 3 by 3 in here, we can see there's 6 possible paths that you could take. If we put 4 by 4 in here, you can see there's 20 paths, okay? So as you can see, it just gets exponentially more complicated as you kind of go through it, right? Now let's try like 7 by 7. How many paths are there for that? There's 924 with the 7 by 7 grid. So let's try 8 by 8. And there's 3,432 paths that you can go through the grid. Okay, so like I said, super exponential. Now I'm going to try 16 by 16. And as you can see, it kind of took a long time to compute this value, but it is 155 million paths. With a 16 by 16 grid, there's over 155 million paths that you can take to go from the beginning to the end, or the beginning or the end to the beginning, however you want to do it. So that's super interesting. And if I increase this just a little bit, like say 24 by 24, you're going to see it really start to slow down. So, the first few basically computed instantly, but this last one is kind of taking a long time to, go through this, this grid, right? So you can see it's still not done. And I don't know exactly what this value is, but I think it's time to stop this and see what we can do to optimize performance, right? So here's the issue, why it takes so long to compute these, is because, like I said, it's starting at the end, and then it subtracts 1 for the x value and subtracts 1 for the y value. Okay, and from this point, it's going to spawn off a whole new function to figure out, okay, what is this value? What is this value? Okay, and from those points, it's going to spawn off something else. Okay, and even if, like, let's say, for example, it starts here at 2 by 2, for example, it's going to compute, okay, I could do this, I could do this. That's how I can go through the path. Those are the possible paths, right? But, like, let's suppose that some other function has called the subtract method and gets to this point, right? We don't necessarily have to compute this again, because we know there's 2 paths. Okay, similarly here, we know the paths that we can take to get to the beginning. And this is why, for this algorithm, it's actually good to start from the end point here. Because I don't necessarily need to run this algorithm from here to find every path back to the beginning for every iteration of this function, because I already know that. So what I can do is I can keep track of basically the paths that were pre-computed, okay? And this is going to help with performance a lot, right? So what I can do is I can say, cache right here, and just leave it blank for now. It's a blank cache. And then what I can do is basically generate some sort of a a cache ID, right? So in this example, I guess I'm going to go ahead and use the coordinates here. So I'll just say x, y, say ID, x and y join by a comma. Okay, so the caching identifier is basically going to be the x and y coordinates that I passed into it. Okay. And then we're going to look up from the cache. So if cache has an ID from, these coordinates, I'm going to go ahead and return the cache value. Okay, so now that we have that, I can run it again. Okay, let's go back to a more reasonable value. Obviously, you're not going to see much. See, as you can see, it's still taking a long time because we haven't set our cache values yet. Okay, so what I can do is I can say result equals what we were returning before. And then I can go ahead and set the cache ID to this value, okay? And then just return the result. Okay, and then I also have to pass in my cache to this function, okay? So basically what this is doing is every time the recursive function gets ran, it's basically setting its cache ID to the result, and then it's using the same cache for every subsequent recursive function call after that. So then you can see our other algorithm is still trying to run, but we can run it again and you can see it's much faster, okay, because we implemented a simple caching layer, not really a caching layer, but it's it's just a simple cache object that basically keeps track of every, basically it just keeps track of every recursive level, okay, and says, okay, if somebody tries to get the paths from this point, I don't have to run the algorithm again for these because I already know what it is. So it just returns it in that case. And then otherwise it goes ahead and computes it. So now we can run this function with huge numbers, okay? And as you can see, it computes that value instantly. So that's awesome. I don't even know what this number is, honestly. It's 430,233,000,000,000. It looks like it's 8 trillion. Okay, so a 24 by 24 grid, you can go through it 8 trillion different paths. There's like 8 trillion paths apparently. So let's crank it up. 48 by 48. So, okay, so as you can see, you just start to get these wild numbers as the sort of paths increase exponentially. All right, so we got the paths working. But like my main issue with these sort of like code golf puzzles is it's like it does absolutely no good unless you can actually like put it into a legit product, right? So that's what we're going to do now. I've actually set up this sort of basic layout and we're going to throw this into a React app. Okay. So let's go ahead and do that now. I've set up just a basic React app here into this counter component. And let's set this up. So basically what we want to do is have the user input the width and height here. And then clicking on this count button should sort of tell us what the paths are, right? So I'm going to just take this count paths function and copy it. Okay, and then I'm going to go back into the React app and add a util called counter.js. All right. Paste that there, and we don't need this result code since we're going to be calling this from React. All we need to do is export the default count paths as the module. We can actually rename this to just count, keep it, or counter, whatever. Just trying to keep it consistent, but I failed at that. But yeah, so we got this nice looking layout here. Doesn't look like Craigslist from the 90s or anything like that. So I'm going to go back into React app here, and I'm going to go import the counter from the utils directory. It looks like I got an error that says count paths is not defined. What? Count paths is not defined on line 9. Oh, right, because we renamed the function, so we have to update the recursion function calls. Okay, cool. So now it works again, kind of. You just have to, like, legit make it work. So the first thing I'm going to do is I'm going to say count paths, okay? And I'm going to make this a function within my counter component. I'm using hooks here. And what I'm going to do is say paths equals counter. And we have to pass in the coordinates here, and we have to pass it in from the inputs that the user has sort of selected here. So how are we going to do that? Well, basically there's a few different things you can do in React to bind a value, but for now I'm going to use state hooks. So I'm going to say maybe I'll make it two different things just for simplicity here. So if you're not sure how React hooks work, it's basically just there's no classes, right? So this function could get called over and over again. So the hooks basically make it so that it will persist these values. And there's sort of two different things that you can use usually to bind values like that. It's useState and useRef. Now useState, the only difference really is that useState basically updates the UI and re-renders components, and useRef does not. So if you want to store some value for, just data purposes, then go with useRef. If you want to, have something that's bound to the UI, then it's probably best to go with useState. All right, and since this is an input, we're going to have to deal with strings. So I'm going to set the value of the input to the width. And then on change, we are going to take the event and set the width with e.target.value. Okay, I would usually make some kind of function that says like update data or something like that. And that would be the function that I would call into. So maybe we'll just do that. All right, so we got that set up. And here's a cool trick. You can make this function have some kind of like a field, right? So you can make the field param return another function, which is going to be the onChange function. Sorry if this is a little bit jargony for new React dudes, but I don't know. I think this is a pretty cool solution. So I'm going to say set data. So what you want to do is use the existing data and use the field property as the parameter to set e.target.value. Okay. Now we don't really know if they typed in a valid number. So in this example, what we could do is say value is e.target.value. And let's see if say number is parse int of the value, and if it's not a number, if number is not a number, we're just going to return, so we won't even update. If it is, then we can go ahead and set the field to the number. Okay, so we parsed an int from the data string, and now we can basically, instead of doing this, arrow function within the onChange, I can just say update data with width, okay? And we can basically just duplicate this input for the height. And we have to set this to the new data.width, data.height. Honestly, I didn't really think about this until I jumped in, so it is what it is. So now let's just say alert when we hit the count button here. On click count paths. So just so that we can see like the data that came out. I could use console.log, but I just want you to see what's going on here. Okay, so you can click the count button. It says width 0, height 0. And if I type in something, you can see it doesn't let me type something that's not like legit numbers. 12 by 12, 12 by 12. Okay, cool. So now the only thing that we have to do is run our counter function with data.width as the x coordinate, and then data.height as the y coordinate. Okay, so with that said, we need some kind of a system to display the result to the user somehow, okay? So to do that, I'm probably just going to say like, where it says enter your coordinates, dude, I'll probably just put the value there, you know? So result, maybe I could do, yeah, I'll just do message. And then I'll just take this that was initially in the H1 and put it here. So that's kind of the default state of the UI. And I can just type in message here. So it's still displaying, which is great. And finally, we can just say set message to, whoa, there are whatever the result is, many paths to get there. Okay, so let's try this out. 16 by 16. Nice. So it gives us that 155 million number in terms of paths. You can also do to locale string, I believe, to get it formatted in the right. Yeah. So now you get commas, which is kind of nice. Alright, so that's probably a pretty long video already. I'll go ahead and cut it here. But let me know if you want to see some other video, and maybe I'll get around to getting back on this tutorial game soon.